So let's see. Hello. Let me just check this. Does everything work properly? Let me see. Let's interact with this. I think we're good. Should be live now. Yeah. Okay. Hello and welcome to the stream, whether it's now or in the future. Right now the whole game thing here is in a state where we should start building an actual game, since we have set up our renderer and different stuff. I did a bit of work offline, but it's really not much. But yeah, we're at a state where we can edit models, add multiple ones dynamically, and so forth. So yeah, I did a start on what is supposed to be. Hello, buddy. How are you doing? So I just added some simple logic uh, as a basis of a sort of turn-based system here. So my intention is to create some game logic in this part of the application layer, and it will be sort of a kernel that handles all game logic. And through that kernel, we will receive whatever output we're supposed to either send to the user or send to the renderer or whatever. So yeah, I also created a function that has the function create game. So let's start by creating a quote-unquote game. I would like for us to create a chessboard. So for that, we're gonna, let's see, so C is the height in Blender. Let's create a very slim, what do you call it, tile here. We will just leave it at 1 by 1 and 1/10 of the width and depth. And we will simply export this as a chessboard tile. We will build our chessboard of tiles. Let's see, so we should drop it in. Tile. There we go. And this is, yeah, we will add a new full layer, chess game, tile. And whoops, I think I need to change the export settings here. Not material, we don't want that. Right normals include UVs, triangulate faces, forward. Yeah, that's good. Let's override it. Okay. So that's our settings. Let's close that. So whenever we create the game, we want to load a model, and Right now it's hard-coded inside our renderer here, I think. No, I think we added it to this. So let's see. Maybe we want a function on our renderer that is called load mesh or something. Draw debug. I'm pretty sure I'm not even using this anymore, but we will see. Am I even using it? Yes, I am. Okay. Okay. This one is not used anymore, as far as I know. Great stuff. Okay, so we would like to be able to pass in a file name. So this is draw functions. UI tick if needed. Only in edit mode. Yeah, I don't think the renderer should have much of an UI, but let's see. Get number of drawable meshes. Well, it could just ask for the instance. Okay. So let's see, let's delete this. Should be fine. Create mesh. So we can pass in a name. Actually, this create mesh function here is probably something that is going to be private and a internal function. And let's do something like static void create mesh const char file path, and this will simply call what we called in our section up here. And this is a const char. There we go. So this is basically the public version. Whoops. Where we can, on the renderer front end, call to this function in order to be able to load a mesh. So load the mesh. Call renderer. Create mesh. And let's see, models slash tile.obj. And this should be fine, right? Yeah. Okay. So this should be done at initialization time for the whole application. And let's see. Okay. And this didn't get called or what? Let's see, print render front end. There we go. And it does create the vertex and index buffer. Create a no meshes to draw. That's not true. Whoops. Mesh. Whoops. Meshes. There we go. I had the wrong one. And we have our tile here. Great stuff. Okay, I think the padding on the debug visuals are probably a bit much. So let's adjust that. There we go. That's more like it. Looks better. Okay, so we load our mesh. And then we should create some kind of function. Where we will, let's see, maybe it should return the unique identifier. Yeah, maybe it should. Hello. The local time here is 17:49. So it's basically early evening here. Okay. Let's see. So yeah, maybe it should return the unique identifier. Because when yeah, let's do that. So this should return this, and this should return this, and then of course these functions here should do the same, and then we return this, and here we return the temp mesh universally unique identifier. Okay, so now we get our identifier here. So now we can actually use the mesh for something. Okay, so let's look up a chessboard. We would like to create a basic chessboard here. which will have 8 by 8 tiles. We could do an array, sort of like some sort of maybe struct tile. Maybe let's create a namespace here. Game, where we create a struct. And then we create some game tiles here. And we do 8 by 8, so that's 48, no, 64. 64 tiles. Let's do a uint 632 maybe. X, Y. Okay. And let's do just some values here for the rows and columns. Tile rows, tile columns. Okay. Our application here, game state tile columns equals 8, game state tile rows equals 8, and then a simple for loop here. Let's do a row. Rows are less than game state rows. R++, and then inside that we do a for loop where we columns, where columns are set like that, and we calculate the then we set the game state tile here by adding C to R times C and setting the X to the column, and then the game state tile Y equal to the rows, and hopefully I haven't messed something up here. Let's see. No pun intended. Game state tiles. So let's see. Okay, so this is not working correctly, I think. Yeah. So the rows, when this is one. Oh, wait a minute. Now I know why. It's because I need to set this, of course, not the C. There we go. Okay. Great stuff. Everything seems to be working then. Yeah. Okay. Let's see. And let's close this and this. Let's create some tiles with the UN32 tile width, UN32 tile height, depth rather. And height. Nah, let's not add height right now. We don't want to adjust that. Okay. So in our system, how big should a tile be? Yeah, I'm alive. If you're interested in doing rendering stuff, yeah, you should definitely learn DirectX 11 or OpenGL as a starter API. Also, I think you should probably combine looking into how Unreal does everything and Unity perhaps, and then you would perhaps have an understanding of the underlying architecture. You shouldn't dive so deep into the code that you try to understand all of the advanced stuff they do, but if you're just interested in doing um, maybe a game, not a game engine um, per se, I would suggest just using OpenGL or DirectX 11, and maybe not speculate too much about the whole architecture thing. So when we're building our grid, Right now, the object gets spawned in the origin, and we could use the origin. I mean, this gets spawned, and the origin is exactly inside the middle of this object here. So whenever we spawn our chessboard pieces, we could arrange the grid so that yeah, it's understandable, but I'm happy to help however I can. It's really complicated, so don't worry too much about that. So if we draw a grid, we could start with the first thing here at the origin and not care too much about it. Thing is, should we scale it or should we just leave it? Maybe we just want a tile size here, rather width of 1. Height will be hard coded to 0.1. Okay. So we should probably create some kind of function here. And this should probably be called not create mesh, but load mesh instead, because it doesn't make sense in terms of whatever call we have to the renderer front end. We don't quote unquote create the mesh. For instance, our application here. I'm not even running in release mode. I have almost 5,000 FPS if I run in release mode, I think. Not always 5,000, but close. But we're really not doing anything complicated, so everything should be pretty fast. We're only running ImGUI, and it's coupled to the backend of Directx12, so that's pretty fast as well. It's a great place to start. And I mean, studying data structures and algorithms is awesome. It's a great place to be in terms of building game systems. Are you using any particular resources for studying your data structures and algorithms? So anyway, we renamed that one. Maybe we want something like great stuff. I don't know when we should do the private lessons. If you download Visual Studio and C++, you can code along. Anyway, let's see. Maybe we would want the globally unique identifier to try out the Discord server. All right, sleep tight, relax ball. Hope to see you soon. Thanks for dropping by. Okay, we will create a object with a float x, a position y, a position c, and with a mesh, and then yeah, I have a Discord server where you can ask questions. A lot, a lot of people on the server do Python, so, but I think you should just watch some video tutorials on how to get started with Python, make some basic programs. Okay, so we would like to pass in the scale x, and we will set that to a default of 1. Scale y with a scale of 1 and a scale c. Yeah, but you know, I'm working full time uh, besides this YouTube channel, so I have a lot of stuff to do. I'm working 40 hours a week on my regular job. Okay, so we can create a object which will call some kind of drawable mesh function here. Let's create a overloadable private version of this. Create drawable mesh where we pass along. Well, you can trust me that you can trust other YouTubers as well. Okay, let's see. So we can mostly create some of this, but so it's dirty. We have the mesh identifier here. You're way too kind. I'm actually not even a professional programmer. Who threatened to bomb your house? I work at a hospital, so yeah. So really not a programmer at all. I have a very long degree in a health related field, so I just do programming and game stuff for a hobby. Oh my god. Did he mean it that he would bomb your house? Or was he just trying to act tough? Let's see, right now we won't implement, or should we implement the float scale x, float scale y, float scale c. Okay. God damn. That's pretty crazy, yo. That's why you go to do so much strength training, right? So we simply pass in our values here. We create the transform from the position and scale. Right now we don't support rotation and we have absolutely no need for that. Let's see, we create the bounding volumes, the transforms, and right now we just assign the index itself, not the unique identifier. Oh, I'm sorry. Yeah, I work on at a hospital. Yeah, I can imagine that Pakistan is pretty aggressive at times. Okay, we could also create a material of sorts, but I don't know. I don't know. Okay, let's do it. Let's do it. Let's do it. Let's do it. Uh, yeah, I have a um, a 2 years master's degree in a health-related science, and then a approximately 7-year specialization degree within that certain area of work. So basically, I have 5 years at university and then 7 years of uh, post-grad training uh, inside. Yeah, so without high school, I've been in the education system for 12 years or something like that. But I've been working a lot. You need to keep at it, boy. You have no what do you call it? Time to get sloppy. Or rather, yeah, I'm just messing around. Let's see. So let's add the material index here. Yeah, maybe you could do something where every time you walk into your room, you need to do push-ups until you have at least done 3 sets for the day. Okay, so inside the actual renderer here, we need to add the We add the material index here. Usually it will be defaulted to 1. Yeah, this will just create the call the internal function. Now we can handle whatever um, handle whatever, what do you call it? Handle whatever logic we want to add on the front end of the renderer. So if we wanted to manipulate this information before we send it to the actual renderer, we could do that. Let's see here, we want to return the okay. Let's create a unique identifier by using the algorithm for it. Let's see. Don't we do it anywhere? Material. Maybe we don't. Load mesh, create mesh. This actually does it. Oh, I had it minimized, therefore couldn't find it. Okay. Okay, we actually do not have a unique identifier for that. Okay, we will simply return the index. I'm from Scandinavia. How about you? Let's see. So we will return. Oh, nice to meet you. Okay, so we could add some kind of tracking here. Um, tile draw index where we store the information. Okay, so let's ask our renderer here to create an object. Whoops, not material, object with our yeah, we have a width of 1 where we cast it to a float times the column plus 1. And the position.y is just going to be like that. And then the position.c is going to be our float tile depth times our row plus 1 times, no, like that. Okay, and this might be, we should probably negate it. The mesh is going to be mesh 0 and material as well. Let's see. Too few arguments. Okay, the mesh cannot be standardized. There we go. Let's see, let's downcast this to a uint 32t and get the buffer index. Okay, let's see what happens if we do like this. Okay, so we actually do get a series of thingies here. Okay, but we're not actually creating them correctly, as you can see here. Okay, so the transform itself is not great. Okay, let's see. Oh, wait a minute. Is this actually correct now? Okay. So the first one here, at 1, 1. That makes sense. Since the center is actually, okay. Let's undo this. Okay, so now we have our first one there. Okay, but this one is okay. Times 2. Okay, so if we pop up that one, pop up that one, and let's do a material of whatever, and we should make it wrap around the number 2. Yeah. Since we have 3 materials, let's do the column plus the row times the column per row. And okay, let's do it by 3 materials. Okay, great stuff. This starts to look like something like a chessboard, right? Let's see. So yeah, well, ImGUI really helps doing things easily. Let's see. Uh, okay. Right now we're copying over every frame, and this should actually be instance drawing, but yeah, we're not gonna bother right now. We're doing basically 64 draw calls to draw these, and they could be instanced, so it would only be one draw call. Also, we copy our constant buffers for these things over for each frame, and it costs us severely in terms of frame rate, but yeah, right now it doesn't matter too much. Okay. Thing is, I would want this to actually, let's see, A, B, B. Yeah, okay. Let's create a temporary transform here because we want to offset that index. Let's see, have I created somewhere else where we can easily, yeah, we do it right here. Okay. Let's copy some of that. Since it works just fine. Let's see. We do have the center. ABB center. There we go. And then the origin. We do have that set. Yeah, yeah. I should definitely optimize that eventually. Let's see. Position X, position Y, and position C. And then oh, okay. So this where we store it, we don't need that. Okay, let's see. ABB center by reference. Okay, so let's delete that. There we go. And we now have our bounding volumes centered around our objects here. Okay. Well, yeah, I think some things are easier in 3D, but oh, well, I don't think that 3D is generally easier, but I'm no expert. Okay, so we have our chessboard here with individual pieces. Um, so that's the start of our stuff. Let's see if I disable the whole debug thingy and simply just run the application here. Okay. Okay. So I would think that if we do something like this and I disable the mem copy here, we won't draw anything, but okay. That's not what's affecting our frame rate. Okay. Let's see, if we don't do the draw calls themselves, we probably end up having a lot more time here. Yeah, the draw calls themselves do create a lot of waiting time. Let's see. Maybe I want. Let's see. Let's time this. Yeah, that doesn't take any CPU time at all. Okay. Okay, let's see. Let's profile this. Update debug. This should not be called very often, I think. Yeah, it doesn't even show. Yeah, it just momentarily shows. So that's not even profilable. This is the create. The profiling. I basically created a macro that's a wrapper for something called a scope timer, which is basically a timer that every time it goes out of scope, it stores whatever time difference there was between the the creation of the scope timer, and then the structure, and then you can link an output and a vector that contains all of the scope timers by pointer, and yeah, then it passes along the timer data. And inside our application, I simply Create profile timers for everything that got collected during that frame. So whenever this goes out of scope, it knows how much time passed since this point and this point of the scope. I'm just wondering. Okay. So let's say we don't create the object itself. Then we do have a very small draw tick here. Usually it's close to unmeasurable. So if I enable this, yeah, the macro takes care of everything for you. And this is of course in shade. Okay. So we're basically also waiting for the GPU a bit. We could, in theory, create frame, or not in theory, we could decide to create so-called frame buffering, uh, which would make us able to submit several frames for rendering without having to wait for the GPU. Okay. So we have our chessboard here. Let's do the first two materials, and let's, instead of these crazy colors here, let's decide on let's see, paint here. Let's find a somewhat chessboard like color. So we could do brown and beige. We could also do black and white. Okay. And the first one is white, so let's do all right. Yeah, there might be some input delay. I could change the no, I can't while the stream is running, but otherwise I could change the latency. But yeah, I heard before that the chat is not very responsive here on YouTube. It probably wouldn't be on Twitch either. Okay, let's see. Let's create some. Okay. And we could, of course, offset this um, by adding the current row here. There we go. And we have our chessboard. Great stuff. And we have our individual pieces here. Not that it matters right now. Right now it's probably more of a quote-unquote problem. And we actually have a blue color here for the third material. And I would like it to be red instead. Maybe with a tint of blue. Okay, so we could do something like this is the highlight color for the chessboard. Anyway, okay, we have now created a chessboard with a series of tiles. We color them accordingly, and right now our application then holds 64 tiles with an X and a Y. This is just a continuous array, so if we ever wanted to do something in terms of updating our tiles or whatever, we could simply iterate over the whole array and then update our stuff accordingly. Okay. Maybe we should then load something like our Paul object here. Let's see. Okay, let's create a scope here where we simply create the board and then create a Paul pawn. Yeah, we don't need this. And let's do Paul here. Okay. And then let's see. Yeah, okay. So we would like to create a Paul object here. So we will ask our renderer to create that for us. Also, I think I forgot to set the tile draw index here. Okay. No, it's not instancing right now. I haven't set up it for instancing. We could do that in a... No. We could do that in a future episode, but right now we don't need it. Instancing is more an optimization. We have to implement it from scratch, but yeah. I can't remember if the other project here, let's see, this one, whether we did instancing here. Nah, I'm pretty sure everything is just also drawn as a, yeah, what do you call it? As standalone meshes. Okay. Yeah, I think so. The ImGUI layer is actually instanced as far as I remember. Okay, so let's create the Paul object here a bit up in the air. Maybe 0. Let's create him a bit floaty. Let's do uim32 t Paul unique identifier here, and let's downcast that to this, and then let's see, Paul index instead, and let's do the third material, and let's start out by not scaling him, and let's see how much scaling we need. Yeah, well, instancing is really great when it's needed. So, but yeah, I guess you would want both methods, both instance drawing and singular mesh drawing. You could also do instance drawing with separate matrices and textures for each sprite, and thereby every sprite in your engine would be the same rather object, but it would get scaled through a transform. Let's see, let's have his size here. Right now this won't do anything, but we will implement it shortly. Let's see, create, okay, let's create a matrix where we do scaling. XM load here, half width, where we simply store. But that's game programming for you. You make a lot of mistakes and then you realize you made mistakes and have to redo stuff. I've done that 1,000 times. Let's see. XM store flow 3. And let's do the vector 3 transform XM load float. Three half widths here, and then our scaling. Okay, so this should shrink Paul as far as whoops. Oh, wait a minute. Of course, I need scale X, scale Y here, scale C. Okay, something's off here. I'm doing this wrong. Half widths. And our default values are 1. Our default values are 1. Huh. Huh. This turned out weird. Let me just think. How did this bug appear? It definitely affects the whole what do you call it? Okay. Let's see, whenever we submit, this is the debug one. Scale, rotate, translate. So we should do something like XM matrix trans scale. Oh, now I know why. Now I know why. It's because I'm calling the wrong function here. There we go. This needs to be this one, not the transform here. So there we go, scaling. There we go. So now our scaling got better on Paul, and our stuff is back to normal. Okay, so it seems like Paul is still a bit too big for our liking. Let's see. That's certainly better. Okay. Let's try creating him at the origin at a downscaled version. Okay. So Paul is now stuck in the ground. He's not exactly on the floor itself. We could do some minor adjustments here. Let's do something like maybe 9.5. Is that better? He's still floating a tiny bit. So let's put in a 3 here. Here we go. Okay. So we do have a Paul inside our level here. And maybe we want him down here at the center like a king. So let's add, maybe add 4 to the C. Well, that's not enough. Then 5. That's definitely not enough. So 6. Oh yeah, I forgot. So it's actually 8, since every tile is 2. Yeah, there we go. So we now have a model. Oh, the bounding volume actually doesn't fit too well, rather. Yeah, I think the yeah, maybe I actually want to do something like scaling. Maybe scaling times transform here. Yeah, that's better. That was the problem. Always scale before translating. Scale, rotate, translate. Okay. Um. So, our game state now has a series of tiles, a simple pole pawn, but right now we can't do anything with it. Let's see, maybe we want a series of units, maybe. Um, drawable index. Wait a minute, this is actually wrong. It needs to go in here. Okay, and let's change that inside our application. Let's do draw index here. Let's create a series of game units. Units. For now, we will just create an array of 10 units. Okay. Let's see. Let's do 16-bit integer here. Player. Also, let's create it's not very rough. It's supposed to shine a bit, I think. Then um yeah, I'm not gonna create a ordinary chess game. I'm gonna do a spin on it. Um so I don't know. Right now we only do it for testing, but um yeah, I'm gonna play a bit around with it eventually. Okay, let's see here. I think I thought about something like a roguelite chess game of sorts, but yeah, I don't know. We'll play around with it. I'm sorry, I certainly don't understand that. Let's see, Paul material. Okay, do we have a bit of shine then? Yeah, our checkerboard here is more shiny than due to our sun thing. Great stuff. Okay. Okay, so we set the game state for the unit here. Let's see. Yeah, that's a good way to do it. Okay. So we create the first pawn here. We scale him down. Um, so right now, we could probably add some game controls here. Right now we do not have mouse picking, but we would fairly quickly be able to implement that. Let's see. Okay, so next turn, right now doesn't do anything but output ended turn for player 1, and then ended turn 1 for player 2, blah blah blah, so forth. So right now our game doesn't do anything at all other than increment the turn. Uh, okay, so maybe our units here should have an X and Y position. Um, for drawing and player assignment, and then positioning on board, and we will simply do this, and this should be something like x equals 0, and the y is then not 0 but 4. Okay. And let's do like this. And this is supposed to be the x times this. Yeah, I'm just doing it to kind of illustrate what we're gonna do. Okay. Um, we could do some public interface. We could also, whenever we call draw, we could update our stuff here. We could also simply adjust the transform. So, for instance, if I do something like I think this is fine. Okay, maybe the order was more nice. Okay, so loading and then creating, then updating. Update mesh transform. Constant sign int object, and then const float position x, position const float position y, const float position c. Okay. Then we simply grab the mTransform on our instance, of course, by taking our drawable meshes object here dot transform transform pointer, and then set the transform pointer here and update it. There we go. Okay, so if we wanted to, we could do something like if we have the active player 0, we create a button player 1 move, and we put that in an if statement. Let's see. Game state units 0. Let's set the x++. Okay, and then ask our renderer here to update mesh transform for our game state units 0 draw index, and then pass in our new values. Times 2, and then right now we will simply pass in our y times 2 here, and then well, the standard value for our C value. No, wait a minute. I'm messing this up. So the C value is set here. The Y value is hard coded right now. Okay. Okay. Let's see. Next turn, it disappears. Player 1. Okay. So we actually do update our model here. It moves, but the bounding volume doesn't update as well. So let's see. We of course just grab the AABB. And of course we do the whole AABBs here. And let's update our translation here. And we update the center. Let's do drawable mesh. Yeah, I create AABBs for simple collision detection of sorts. But there's no physics. I just need to use them for mouse picking, so that I can actually click an object on the screen if I want to select it. So it's not really used for um, collisions right now. Yeah, it's pretty hard, but um, let me show you in a sec. There we go, and let's just swap this. Let me just get this done and then let's see. There we go. So the OBJ origin here, and then there we go. So let me just see if this works. Nope, we're not done yet. Huh. Huh. Let's see. So we're not updating that. Maybe if I do, yeah, okay. So it's related to the update function instead. Okay. So let's set the object to dirty here. And then everything should be fine. Yeah, there we go. Okay. So let me just show you the other thing that I created here on the channel before. So let me see, what is the shortcuts? Let's see. I can't remember the shortcut keys. Let's see. Okay, so toggle debug info. As you can see here, I created a a level editor where I can click every object and then it gets selected. So that's what I'm gonna use the AABBs for. Set to edit. I can't remember. Oh, well, anyway. Can't remember how to enable the different stuff here. I think maybe, no, F12, it doesn't work. Let's see. And yeah, as you can see here, we have collision detection on the mesh corners here. With some physics. Okay. So we can now move our pole object here. Let's do... Yeah. So basic movement here. Okay. Well, I need to go do some cooking and maybe eat some food and yeah, I don't know if I'm gonna do more streaming today, but yeah, I think we got some nice work done. So the next thing that I would want to do is to create some more game logic. Maybe we want to be able to what do you call it? Uh, Maybe show a movement pattern or something. Maybe I should just implement the whole mouse picking thing. Make everything clickable. That could probably be nice. Yeah. Yeah. Yeah, that could probably be nice. Yeah. But I'll figure that out during the next episode. So in general, I think this will be the kernel where the computations are going to be made. So for a basic chess game, we need to create some. We need a turn system. We already have that in place. We can increment the turn and it. Hello, buddy. How you doing? I'm just about to wrap this episode up here. No, when I do object picking, or rather mouse picking, I will just cast a ray from the mouse into the scene and check for the AABBs, whether they get intersected by the ray, and if they do, we pick the first one or the closest one, and then return whatever object ID that is. So let's see. A bounding volume here. Yeah, it should probably store the object ID. Yeah, it will be a for loop. I'll just iterate through all these. Well, I guess you could segment the whole scene into chunks and just look within a certain chunk, but I think that's what we did in this system here. Picking the closest one, I think. Let's see. Yeah, even though this one is behind that one and could be picked. I mean, yeah, I'm pretty sure it just checks for the closest one. And it's not that expensive to do a well, the C buffer is only on the GPU right now. You could do a sort of like CPU side C buffer, but how would you, in 3D space, how would you account for the camera angle and the raycast itself? Most mouse picking is handled by iterating over a series of bounding volumes, usually AABBs because they're pretty fast. You could also use bounding spheres. Bounding spheres would usually get you a more unprecise picking function, I guess. But I don't know how the information would be available to the CPU. But I'm no expert, so. Um, no, I calculate them separately. So let's see, did I close the Visual Studio? Let's see. In this application here, I whenever I ask the renderer front end to load a mesh, I load the original vertex data and then call an internal function that uploads it to the GPU, the vertex data, and then calculates an AABB for that particular mesh. So this uses a series of functions where we find the most extreme points along the x-axis, the y-axis, and the z-axis. Well, raycasting is normal in 3D applications. It's basically how most interaction is done. So whenever the mesh vector, rather vertices are loaded into an array or structure or a vector, I can iterate through all the vertices and decide which points have the minimum and maximum x value, y value, and z value, and then I can compile it into a center for the AABB, and then 3 half widths along the x, y, and z axis, and then I can store that in a alongside the other mesh information. Uh, let's see, temp mesh here. And I basically do this vectorized, so so it's pretty fast. Let's see. No, no, I don't think so. Let's see. No. So what you do is you take your axis and all your vertices, and you project each vertex alongside the axis, uh, which means that you calculate the dot product between the axis and the point, and um, whatever is the highest and whatever is the lowest in terms of projection is your minimum and maximum point alongside that direction or axis, and you simply store that, and you do it for all 3 axes. The dot product between 2 vectors is how much they're pointing in the same direction. So if you do it for each axis, you will automatically get the highest possible projection, which is the maximum point, and the lowest, most negative number, which is the minimum point. And then in terms of determining the ABB half X size and half Y size and half Z size, I of course take the absolute value of the maximum minus the minimum and divide it by 2. And the same thing for the center, only opposite. So this bounding volume here is actually automatically generated whenever I load the mesh. All these bounding volumes here are automatically generated, and I only need to update them, the sensor value, whenever I move the object. And since I'm already updating the transform, it's usually a few computations, as you can see here. I simply transform the AABB center. And then for debugging purposes, I mark the whole thing as dirty. So it's just a dot product that determines the minimum and maximum values. Okay, let me try to explain it again. Maybe I went over it too fast. So the function is called find extreme points along direction. So that means I want to find the most. Oh, I think it's. Oh, it's not passed. Oh, okay, I copy it. Yeah, I could of course do that. That's probably better. You are absolutely right. A vector pointer. Do you mean the... I'm sorry, we might be having a misunderstanding here. A vector can be two things right now in this program. A vector can be a vector as in SIMD, um, vectorized floating point unit, or a vector like a series. Oh, yeah, exactly. So do you mean this or what? This part here? Here? Uh, this one? This function declaration? Or was it up here? We're looking for the needle in the haystack. Which vector? So this one? There's a bit of delay, so I don't know whether I got the right one before like 10. Okay. And you were asking, why did you, oh, not just a reference? Well, you could use a reference anyway. Reference and pointer is basically the same in C++. Um, Sometimes I write things more C style, which would be a pointer instead of a reference, but they're basically the same thing. Reference is just a C++ wrapper over a pointer, and it tells the compiler that you want to not copy values but pass them by reference. But yeah, you can use whatever you want. Also, reference means that you don't have to use the whole arrow thing. You can simply type dot. I'm not well, I'm doing things a bit more C style, so I really don't like a lot of getters and setters. I would rather just have a structure where you can access all member variables, but I think it's a matter of taste. I think once things get optimized, you're still just grabbing a pointer to a memory index and address rather, and accessing some information. But I guess it would depend on what. Yeah, I really like using structs for everything. Did I explain everything all right, FTC, or because I'm probably gonna wrap this up for now. Definitely not a master, but I'll try my best. Anyway, thanks for tuning in. Let's see. I think that will be it for now, at least, maybe for the whole day. Yeah, next steps are to do some more game logic stuff. I mean, we got some units, we got some tiles, but we gotta do something with that stuff. Anyway, I think I got myself distracted. We need a turn system, we need a tile system, we need a unit system, then we need some AI system. Let's do the quote unquote. Uh, and this system needs to highlight a square for the movement system here of sorts. And let's do outside engine logic, mouse picking. Yeah, so the next step would be something like creating some movement rules. So for instance, if I could click Bob, or rather, I'm Bob, I mean Paul, click Paul, and then the system could show me the available options in terms of where can Paul move, and then I should be able to click within those options and move him. That would be nice if we got to that step next time. Yeah. Yeah, so that's the goal. And then we can start building on the game logic. So the logic itself will develop quite slowly because we will also create the other systems to handle whatever We need to make the game actually work. So yeah, but we have dynamically created the chessboard, colored it, and loaded a pawn pole. Just by writing this simple loop here for the chessboard and this information here for the pawn. No, you simply what you do is you, as far as I remember, you transform the ray you cast into object space, and then you check whether the uh, the ray intersects um, the so-called slabs of each side of the bounding volume, the AABB. Yeah, so you, as far as I remember, you usually transform the ray into the relevant spaces. I can't remember if there's a broad search and then a narrow search. I can just go through the logic we implemented in the other engine. Let's see, blah blah blah. So it's um, at least for this version, a lot of people do mouse picking with raycasts and bounding volumes. You could also do it with a bounding sphere, as I've mentioned, but the bounding sphere will not. It will typically be larger than the actual bounding volume if it's created like an AABB. And of course, an OBB will be even a more tight fit, but since the raycast against AABBs are uh, fairly easy to check, um, we let's see. How would you uh, actually um, well, I guess you could do a geometry buffer like in deferred rendering, and you could for each pixel map an object ID. So each pixel would basically be an index into the geometry buffer and thereby some sort of object ID, but then you would store the object ID on the GPU. Why would you want to store that? The GPU doesn't care about the object ID. It really has no use for it. So it would be some kind of like thing where you calculate it on a per pixel basis and then you have to fetch it from the GPU and pass it back to the CPU. Yeah, I'm not sure how you would do that efficiently. I mean, it doesn't take very much time to do several checks against the AABBs on the CPU side. Everything will probably be fetched into cache fairly quickly, and if you just vectorize your calculation. So as you can see here in the other application, when we do mouse picking, we first get the um, screen size and the projection matrix of the camera, and then we translate the mouse X and Y position into normalized device coordinates on the X and Y, and then I'm pretty sure it would be way faster just to do it CPU side. And you would store like millions of indices in the buffer for on the GPU for no apparent reason. Just imagine in 4K, millions of indices, object indices, would you store? I don't know. I don't know. But yeah, so you translate the um, mouse screen coordinates into object or world space x and y coordinates, um, and then we have the x and y and z axis of the ray that is being cast, since we're casting it into the screen. Always forward is negative c in this system here, and then we get the view projection matrix for the camera and inverse it. And by that, I think we get the probably it would probably be yeah, in world space, or yeah. And our algorithm here get closest intersection on the ABB. Simply this query. Yeah. Anyway, you would only do it on mouse click anyway, so if you had a scene with a lot of what do you call it, uh, AABBs, you could of course chunk the whole thing. Yeah, yeah, you would have to do some kind of um, um, for instance, binary search tree, not necessarily a classic binary search tree, but some kind of search tree, or um, a 3D bounding volume that chunks every part of the scene. I also think that the algorithm that we just looked up, when it tries to check for the intersection, it has a so-called early out, meaning that if the first check is not true, it knows that the ray cannot intersect the AABB and it will just exit fairly quickly. So that's also how you optimize your algorithms for collision detection and checks against bounding volumes. Make sure you have an early exit if possible, so you don't need to do all computations for every object, but maybe can skip a lot of them. That's also why you want to consider whether um, you should transform the ray into local object space or world space in terms of checking for collision, because, or intersection rather, because sometimes it might be faster due to early outs. But yeah, I'm no expert. I'm definitely no expert. All right, I really gotta go now. But thanks to everyone who dropped by. Uh, have you implemented it yet? Or is it just an idea still? Oh, okay. So you've created a geometry buffer and all the sorts for the deferred rendering. Oh, cool. You should send me some screenshots. Hello, buddy. Long time no see. It's a whole get together today. Oh, congratulations. That's awesome, man. That's awesome, man. So you're a game programmer. That's awesome, man. Wow, that's way too much. You did all the hard work yourself, man. You give me too much credit. Have you been out celebrating? You're all way too kind. The channel is called Bad Programming Guide for a reason. We're just a lot of dudes out hanging out, trying our best. Oh, that's awesome, man. I'm happy to hear that you went out and got an internship. That's great. Fingers crossed you'll find something interesting. Oh, that sounds fun. That sounds really fun. You'll soon be a game designer then. Maybe you can teach me a thing or two. Hello and welcome. All you guys are tuning in when I was almost about to end the stream. I appreciate you all. You're way too kind. Way, way too kind. It does feel good to be back hanging out with so many nice people. Yeah. Let's throw an Discord graduation party for the Sage of Wisdom. We might as well. We should develop a internet-based game, party game we could use for celebrating different stuff. Yeah, I do. I eventually got around to creating it. I can't even remember where the link is. Let me see. Yeah. Let me just add it to the description here as well. I think this should be the link. I can't remember the name. I haven't done anything else but the basic setup, I think. Let's see. Whoops. Let's just move it off stream. Hello, hello. All right. Since we got the Discord link server, Discord server link sorted, I'll be ending the stream and I'll be doing some cooking. Yeah, we got a plan for the next couple of streams where we will build out our game kernel and do some interaction with the renderer itself. Uh, Eventually, we will do optimizations, but right now we will just do fast iterations and different systems to support that iteration and potential gameplay. But yeah, thanks to everyone who dropped by. Feel free to comment, like, and subscribe. Hopefully, I'll be seeing you in future streams. It's really nice to have so many great people join the stream and hang out in our community here. I'm happy that a lot of you seem to be doing so well. Keep on trucking and stay focused and healthy. All right, take care. Bye bye.